Hey, amazing people. We've got this example here where we've got a normal distribution, has a mean of 65.2 and a standard deviation of 1.3. And what we're asked to find is the percentage of scores that lie between certain values here. Now, we've got the graph over here with the percentages laid in partly for us. Now, in the case here, if we were to look at the proper percentages, we would see that this center region has 68%. We would see that this further region then out here, this has 95%. And lastly, this last region here, and this last region, which is 99.7%. Now, when we're dealing with these questions, it's actually not necessarily helpful to have those points here. So it's often a lot more helpful if we can break it down into these smaller parts. So what we might do is get rid of these, so we've just got the smaller parts. Now, in the first one here, what we're being asked to find is between 61.3 and 65.2. Now, one of the first things you should notice is this second value here, 65.2. This is actually the mean, which we were asked, which we were given in the question. So what that means is on our graph here, let's add this on now. So 65.2, that's going to be the middle section of our graph. Now, from here, we need to be able to break up each part. And so in the first one here, well, we've got the mean, but then 61.3, well, this is going to be equal to 65.2, and we need to work out how much it is. In this case here, this is 3 times 1.3, with 1.3 being the standard deviation. So that's where I've gotten that from. So as we work this out then, that tells us then that we are 3 standard deviations away from the mean. And so what that means, given we've got a lesser number here, that means we're going to this point here. And so the area we're seeking to find on the graph is this area here, which is being shaded in. Okay, this is the area we need to find out here. And now you can see from these numbers that we have that we can kind of use them a little bit to help us work it out. So when we're working this out then, effectively what we need to know is we need to know half if we take those regions there. Now we can look at it this way, and what we could do is we could do 50% minus 0.15, and this is going to give us 49.85%, which is the correct answer. Another way we can look at it though, if we don't have these small numbers and we only have the big ones, when we're going between 3 standard deviations away from the mean, well, this is equal to 99.7. What we're going to do is take 99.7, and since we're only using half of the graph, we're going to divide that by 2. And when we do that, we also get 49.85%. So what this is saying is 49.85% of the scores are located between 61.3 and 65.2. Now in the second example, what we've got here is we've got 65.2, which is our mean, so that's one of the values we're using again, and 66.5. So one of the things we want to do is we want to be able to think about this and what this is going to look like. So that 66.5, well, that's going to be equal to 65.2, and it's going to be 1, for adding 1 of the standard deviations of 1.3. Okay, so what we've got here is we've got 1 standard deviation, which we're trying to calculate the value of here. And so if we go to our graph here now, what that means is we're going from 65.2 and 1 standard deviation away to 66.5. That's going to be just this region here. Now, way to go about this, we can see from this graph quickly that that area I've colored in, well, that means we've got 34%. But if we don't have that and we've got the other graph to look at here, well, that's going to be 68%. And since we're only using half of it in this case, we just divide that by 2. And when we do this, we get 34%. And so that's how we get that second score here. So 34% of the scores are located between those values. Now for this last one, we've got 2 values. We've got 62.9 and 69.1. So one of the first things we want to do is we want to be able to break it down and understand what's happening here. So in the first instance, let's look at 62.9. We want to know how many standard deviations away from the mean that is. So we're going to do, for this, we're going to do 62.9, and we're going to make that equal to 65.2 minus, and in this case, it's going to be 2 times 1.3. So what that is that's 2 standard deviations away from the mean. So that's one of the values we're dealing with here. Now, the other value we're dealing with, we're going to do a same thing. So this time we've got 69.1. This is equal to 65.2. In this case, it's adding, and it's going to be 3 standard deviations away from the mean. So it's going to be 3 times 1.5. So what that means is we're finding the area of the curve from 2 standard deviations below to 3 standard deviations above. So that's going to be this region here, which is being shaded in now. So it is a fairly significant region which is being shaded in here, which we need to find the value of. So in order to do that, so this is 3 standard deviations, what we're going to do is we can take the values from the graph and add them together. That's one way, but let's avoid that altogether here. Now we know, for example, when we have 2 standard deviations, that's just looking at one side of it. So we're just going to look at this half here. Okay, so one thing we can do is we know that's going to be 95%. So we're going to take that 95 and we're going to divide it by 2 for just that one region. Then for the other side, well, that's 3 standard deviations, and we know that's 99.7. So we're going to do 99.7 and divide that by 2 as well. And that's going to give us the other side here for those 3 standard deviations. So what we're effectively doing is we're taking the 2 halves and then we're adding them together to work out what our total value is going to be. So in this case here, 95 divided by 2 is 47.5. And then on the other side, we've got 99.7 divided by 2. And this is going to be equal to 49.85. So what we need to do is add these 2 values together now. So 47.5 plus 49.85. And when we add these together, the answer we get is we are going to get 97.35%. So this is saying that 97.35% of the values are located within the shaded region of this normal distribution.